So again, thank you everyone for joining our August meetup. If we were not recovering from a pandemic, we would normally host this event at Fannie Mae's office in Reston. Our point of contact at Fannie Mae, Barb Gilday, is here this evening. Thank you, Barb, for joining. Is there anything that you want to say at all before we get started this evening?
Hi, everyone. I am looking forward to hopefully someday soon being back in the office and having this live instead of virtual. So
Awesome. Thank you, Barb. I also want to take this opportunity to let you know that we are looking for a speaker for a November meetup. So please feel free to reach out to me directly. You can ping me in the chat during the meetup or contact the meetup group after the meeting to let me know that you're interested in speaking. I also want to advertise a few upcoming events. First, Coveros and TechWell will be hosting Star West, which will be held at the Disneyland Hotel in Anaheim, California from October 3rd to 8th, and will offer a robust virtual component as well. Registration is open, and I'm going to paste a link to that in the chat. And I, of course, also want to mention that Agile DevOps East will be held from November 14th to 19th at the Caribe Royal Orlando, and we'll also have a virtual component as well. You can register here, the link that I just pasted into the chat. I also want to encourage you to submit articles for the Sticky Minds website, which is a great place if you're a testing professional to get your ideas and work recognized. I'll paste a link to the submission guidelines for that technical publication in the chat as well. With all of those announcements out of the way, I want to go ahead and introduce our speaker this evening from Coveros, Jenna Charlton. Thank you, Jenna.
No problem. Hi, everybody. So I am Jenna Charlton, and this is Black Box Test Design. What I would encourage is if you have questions, and you might, please just feel free to yell them out. I am an instructor full-time, so it takes a lot to rattle me. Also, this is really hands-on. So if you don't have paper and pencil, grab them. You will need them to kind of solve some of the questions. This is very mini workshop-y, which is the way I like to talk and to teach. I like everybody doing things. So just a little heads up. So a little bit about me. Testing is my jam. If we were together in person, I would give you that sticker. Unfortunately, we're not together in person, so you get to see the sticker instead. Also, my Twitter handle is SheWrestleSTest. That's the best way to get a hold of me is on Twitter. I have been testing really for more than 10 years now, but I just round it to 10 years because I've lost track. I am a senior training consultant for Coveros. That means that I teach, I develop instructional content, I do coaching, and I love specifically working with testers, especially because that's my background. But I also do a lot of Agile training and coaching as well. I'm a cat mom. One of or both of them may make an appearance. There is no stopping them if they decided they want to come up on the desk. So you may see a cat or two. I'm a deacon at my church. I love pro wrestling. I love punk rock. I am really into web accessibility. That's kind of my other thing in technology outside of testing. Is that I'm really passionate about advocating for web accessibility and making the web more accessible to disabled users like me, because I do consider myself disabled since I am ADHD. And I always share that because it's important to normalize talking about this stuff. So there we go. That's my personal pitch. So the things we're going to be talking about today, we are going to do a real quick overview of what it means to do black box testing. We're going to talk about equivalence partitioning, 2 and 3 value boundary analysis. We're going to get a little bit of pairwise and a little bit of decision tables. And really, that's only if we have time. There is probably more content here than we have time for, because this was really built for 2 hours for a mini workshop I did for someone. And I liked it so much, I said, I'm going to keep it and keep doing it. And we get through as much as we get through. So, Jonathan, how long do we have, by the way? Is it an hour? We go till 8?
Yes, we do have 1 hour until 8 o'clock.
Okay. Yeah. So, little bit about what it means to do black box testing. We use these black box techniques to help us identify test cases, both for functional. When we think of functional, this is what the application is supposed to do, and for non-functional, this is kind of the how well does the application do it. There's some confusion around what functional and non-functional are because, let's be honest, they are named really poorly. Non-functional things are still functional, like they still work. They're not static. So when we think of functional, these are things related to like the requirements and user stories. And when we think of non-functional, we're talking about the quality characteristics, also known as the ilities. So security, reliability, and then the things that aren't named with ility, but are like performance and stress and capacity and all that good stuff. So we can use these techniques to help us identify meaningful test cases for both functional and non-functional requirements and functional and non-functional testing. And the whole idea here when we think about black box is this is based in kind of obfuscating the underlying code, the underlying architecture, the underlying infrastructure of the application. The point in doing that kind of obfuscation, intentionally preventing ourselves from thinking about the underlying components, is that it prevents that cognitive bias of, well, I know how this actually works, so I don't need to test it. Because just because we know how something is supposed to work doesn't mean it's really going to work that way. So this gives us a chance to get a view into that without the bias of saying, well, I just know that's going to work, so I'm not going to touch it. It's important to keep in mind, we can use these techniques for anything. We can use this for component level. We can use this for system tests. We certainly can use this in developing some acceptance tests and certainly in automation. So let's start with our first technique. We're going to start with talking about equivalence partitioning. In equivalence partitioning, we are designing test cases meant to exercise the unique partitions that are relevant to the requirement. We're going to develop one test case for each partition that we're going to be discussing, and I'll kind of walk through what a partition is. When we think about partitions, we're looking at legal and illegal or valid and invalid inputs. So typically we're going to have valid partitions and invalid partitions. It's important to keep in mind that we can have subpartitions. This is especially important when we think about something that's that we're looking at that's a continuous range, or we're thinking about sets of valids and invalids that might be kind of umbrellas. And I don't want to give too much away because then I'll give you the answer to some of the challenge questions. Our coverage, to get to 100% coverage on equivalence partitioning, is one test case for each partition and subpartition. Now, everybody says to me, well, that doesn't sound like enough testing. 100% coverage and enough testing are two different things. 100% coverage is just enough to exercise the partition fully. Doesn't mean we wouldn't want to consider running some additional tests as well. And that's kind of the problem with coverage in general as a measure, is that what measures as 100% doesn't really reflect the reality of what fully covering something means. So let's take a look at how we use this. Let's start with looking at a continuous range. Continuous range here, we're looking at maybe a mortgage application that we have a minimum that they need to make at least $500 a month and a maximum that they can't make more than $6,000 a month. So 500 inclusive to 6,000 inclusive. And that would be a continuous range because we're going to accept all inputs in that range, regardless of whether it's a whole number or a decimal, because it's continuous. But then we have another range that we can look at, and that's thinking about discrete ranges. Discrete ranges are important because this is when we're thinking about things like integers. So we're not looking at an inclusive range of 500 to 6,000 that could include decimals and include fractions. Now we're looking at distinctly 1, 2, 3, 4, 5. They have to be whole numbers. In this case, we're looking at greater than or equal to 1, less than or equal to 5, because it's inclusive. Here's where this matters. We're thinking about potential inputs. We need to think about what would our potential inputs be that would be valid and invalid. And something I forgot to mention, these techniques kind of build on each other. So you might be saying, well, you're saying I just need one thing within the partition. What about the other things we need to think about? How do I know about kind of what's in between partitions? A lot of this stuff builds. So we kind of walk before we can run. Right now we're crawling. So if you're saying, I feel like there's something missing here, I promise we're going to get to it. We just haven't quite gotten there yet because we're still crawling. So that's a range. Are these ranges of numbers either in continuous or a discrete range? Then we've got non-ordered sets. And non-ordered sets is when we're looking at values that we can enter into, into some sort of input. In this case, we're thinking about something like a veterinary practice, that the vet will accept cats, dogs, and birds. Now, remember how I said there might be subpartitions. Well, if we think about dog, cat, and bird being the partitions, now, if you're a cat owner, you're probably calling and saying, hey, I want to bring my cat because, like, you know, breeds of cats are like the orange cat that you found behind the dumpster. You know, that's the way us cat people roll. But dogs, you typically say, like, I want to bring my dog, he's a lab, or I want to bring my dog, she's a Burmese mountain dog. So under that category of dog, that's a valid partition, we're going to have the subpartition of the different breeds of dog, or in the case of birds, the different species of birds, or in the case of cat, if it happens to be an actual breed of cat, the different species. And then we've got one more here, and this is Boolean values. And when we look at Boolean values, this is thinking about valid and invalid inputs based on there being only one valid input and everything else being invalid. Thinking again about that mortgage example that I mentioned in the continuous range of 500 to 6,000, we have a requirement that it has to be a private person or persons that can apply for a mortgage. What that means is that we can have Jonathan apply for a mortgage, or we can have the Andrish family apply for a mortgage, but we can't have Coveros. So acceptable input would be Jonathan or the Andrish family. Unacceptable would be Coveros because it's not a private person or persons. Here's why this matters. If you think about designing test cases, we're looking to expose what might have been missed. It's really valuable to know that you can design a test case and understand the way to design a test case that would show that maybe we're handling numbers incorrectly. So we're allowing for a continuous range instead of a discrete range. When we need to just accept those individual numbers, we should only be looking at a discrete range. So let's look at what this looks like. Sorry, this gets a little bit brighter. It goes back and forth. But thinking about that mortgage example, where our acceptable inputs are 500 to 6,000 inclusive, if we were to draw a number line, less than $500, so $499 and less, that would be invalid. $6,000 and 1 penny and more would be invalid. So we have two partitions here. We have a valid and an invalid partition, which means that we have one valid partition and an invalid partition with two subpartitions, one being too low, one being too high. Thinking about the example of the cat, the dog, and the bird, those are acceptable inputs. Everything that falls under cat, dog, and bird is a valid input. Everything else is an invalid. And for cat, dog, and bird, we essentially have 3 subpartitions because we can accept any type of dog, cat, or bird. Another way to visualize this, by the way, instead of using these number lines, is to use these boxes. And I kind of love these little boxes. For me, when I think about some sort of input value, and it's not something that's numeric, I like to think of it in terms of boxes. This works really well for me because I'm a very visual thinker. If you're not a visual thinker, this may not help you as much. But in this example, I have a dog, a cat, and a bird in the valid box, and I have a pig, which is an invalid entry in the invalid box. Trying to keep an eye on the chat. So I'm going to give you a challenge question. I want you to try this. Everybody, is there like a reaction function in here, Jonathan?
That's a good question. Let me try to figure that out.
Okay, if not, it's totally okay. Because you know what, I don't think there is. So hopefully everybody's got pencil and paper. I was going to ask you to give me a check mark if you are all set with pencil and paper, but I don't think that's in this tool, but that is okay. Here's what we're going to do is I want you to try this, and then we're going to talk about it. Hopefully there will be some people brave enough to give me their answer on it. So a new fitness startup is selling on-demand classes. When purchasing select packages for classes, there's a progressively higher discount offered. We need to test to ensure that the right discount is being offered for the right packages. Here are our requirements. You have to purchase a minimum of 5 classes at a time. Classes can only be purchased in increments of 5. So you can purchase 5, you can purchase 10, can't purchase 6, can't purchase 4. 5 classes cost $100. The minimum number of classes that need to be purchased to get a discount is 10. 10 classes purchased results in a 10% discount. The max number of classes that can be purchased at a time is 25. And the discount is going to be equal to the number of classes purchased, and we cap that at a 25% discount. Given the above, identify the valid equivalence partitions you would need to have 100% coverage of both the quantity of classes and the final price for the package. So you should have 2 sets of numbers when you come out of this, 2 sets of partitions, one for dollar amount, one for number of classes. So I'm just going to sit back and let you work on this. Please, by the way, tell me if you have any questions while you try and solve this.
Testing, testing. Can anyone hear me?
Yes. Yes. I
Oh,
can.
okay. All right, good. Thank you.
Yeah, I'm just giving everybody time to finish. Fortunately, with Jonathan's camera on, I can see that he's still thinking. All right, everybody do me a favor. Just type done in the chat when you finish. All right, I've got 3 people telling me they're done. Just going to give another couple of seconds to see if anybody else responds, and then I'll go over it. All right, let's talk about this. Let's see how we did. Who wants to be brave and tell me how much and how many classes the first partition are? Who wants to try it?
Is it 11?
Say that again, Tom?
Is it 11?
No. So we should have we should have the amount of classes and the dollar amount. And the first one is actually tells you in the requirements what the first partition is.
So would you have a partition for the ones that are in between the right numbers?
Those would be the invalid.
Yeah.
So I guess technically yes, but it would be all invalid. Like they wouldn't be individual partitions. I'm more interested in the amount of classes that are valid and the dollar amount for the valid.
Is it 5 then?
And how much?
It depends on the amount. So 100, 180, 255, 320.
Just the first set. So 5 classes is how much?
100.
Perfect. Who wants to try the next one? Come on, you got to talk to me. I like to talk to people. Okay, so Tracy says 10 classes for $180. That is correct. How about the next one? Maybe you know what the next one is?
Is it 15 for $255?
Mm-hmm. That's it. How about the next partitions? I'm going to swing back to Tom because it sounded like he had all of them. Putting you on the spot.
I had 20 for $320.
Yep, perfect. There's one more. What's the last one?
You do it, Jonathan.
25 for $375.
Yes. Awesome. We got them all. Also, I like getting to pick on Tom. I don't get to do that very often. Doing this now, yes, you are probably not going to get a requirement by the way that looks like this. They're probably not going to give you a word problem, right? But this gives us an opportunity to think through what it means to identify these partitions. Being able to identify them is the first step to developing test cases that are meaningful, that truly exercise what is and isn't valid. Does anybody have any questions about this idea of equivalence partitioning before we try something else? Okay. So let's try boundary value analysis. Boundary value analysis is an extension of equivalence partitioning. So this is kind of the next thing adding to this after we identify those partitions. Now, if you were thinking like me when you learned this, you were probably saying, well, yeah, great, we know what's like in a partition, but don't the boundaries around the partition matter? And they do. And that's where we get to this idea of boundary value analysis. So we think about both what's in the partitions and what the boundaries are that are kind of the spacing between the partitions. We base these test cases based on whatever those boundary values are, but we can only use this technique for sequential numeric data. Anybody have a guess as to why it can only be sequential numeric data? Why do you think we can only do that when we're thinking about this idea of boundaries in a range?
Because it's boundaries. I mean, you can't have like, right, cats be boundaries, right? Because, but I don't know how to explain it, but yeah.
But you're exactly right. We can't identify what's the beginning and what's the end.
There you go.
Yeah, what makes one of these higher than the other? So we can only do this with numeric data because there is no context to, like if we were to think about colors, is red or green the start or the end? Or cats, is, you know, I don't know, a Norwegian forest cat versus what's a Bengal, like which one of them is the start and the end? There's no way to tell. The only way to tell is if we're using sequential numeric data. Now we have two different ways that we apply this technique. We can do two boundary value analysis where we're just looking at the boundary, or excuse me, the boundary itself and then the value above it. Or we can do three boundary value analysis where we're looking at the number below the boundary itself, and then the value above the boundary. So two different ways to apply this technique. The reason we would choose two or three value is going to be dependent on what we're building test cases around and our context, because of course testing is context dependent. And our coverage here, just like we talked about coverage for equivalence partitioning, in this case, our coverage is one test case for each invalid boundary and one or two for each valid boundary, depending on whether we're talking about two or three value boundary analysis. So the reason we would choose either two or three boundary analysis is based in the context. For the most part, if we're working with whole numbers, we're probably going to go with two boundary value analysis. That's why you have here this example of a customer can purchase up to 10 cookies, which means that they can purchase between 1 and 11 or greater than 0, less than 11. Why they can only purchase up to 10 is beyond me. Don't limit me on cookies. I will buy as many cookies as I want. But for some reason, this baker has this rule. Maybe they're really special cookies. So this is what our number line would look like. We'd have 0 and 1, 0 being below the boundary, 1 being the boundary itself, and then 10 being the boundary itself, and 11 being over the boundary. And if we take this just a step further to put the pieces together, if we wanted 100% coverage on the equivalence classes here, we would just need one test case for too low, one test case for too high, and one test case for somewhere in the valid partition. If we were to then apply the boundaries, we would need one test case for 0, one test case for 1, one test case for 10, and one test case for 11 to get to 100% coverage. But what if we're dealing with, so there we worked with whole numbers, but what if we're dealing with decimals, fractions? something that isn't just a whole number. That's typically where we go to 3 boundary value analysis. Now, here's the big thing with why you would choose one or the other. 2 value, typically whole numbers, or when precision isn't terribly important. 3 value we tend to choose because there are decimals or fractions, and because numeric precision is important. There are a lot of reasons that numeric precision might be important. One is this example. This is money, and we always need that precision when we're talking about monetary instruments. But there's other reasons we might choose this as well. Can anybody think of another example where this kind of precision would be really important, where we might need to use 3 boundary instead of 2? Let me ask this. If you were testing something like a voltmeter, would you want to use 2 or 3 boundary, do you think? You may have a guess.
You might have to tell some people what a voltmeter is.
A voltmeter measures electrical current. And hint, it has decimals.
I'd probably
You
go
would
with
need
3.
3 boundary.
Yeah,
Because-
yeah, we would
Well-
absolutely go with 3.
Yeah.
Absolutely.
Many devices have, they output different voltages. So
Mhm.
some are bigger than others. You know, you got a blender, and then you got like a car or something.
Yeah, yeah. And we would definitely need precision there. What about GPS coordinates?
I'd probably still go with a 3.
Yeah, yeah, we would absolutely go with 3 on GPS coordinates, especially because GPS coordinates are typically represented by a decimal. So we would need to ensure that we're not rounding, that those numbers don't get cut off, keeping in mind that when we think about GPS coordinates, it extends to multiple decimal places. Same thing with money, by the way. When you deal with beyond just the dollars and cents of like consumer, thinking about, you know, online shopping, you're not extending past two decimal places. When we think about trading platforms and things like that, they can extend to 4, 5, 6 decimal places. Some languages automatically round. We have to ensure that there wasn't a mistake made, that that floating decimal doesn't round in error. I think that's how you phrase it. But that might be another reason that we would choose 3 boundary. All right, so we've talked about why we would do one or the other. But here's an example of doing 3. So here we have that the customer is charged a service fee for small orders. They can't order something less than $1. They have to spend at least $1 for their purchase to be valid. So 99 cents and below, it's invalid. We won't allow the purchase. Between $1 and $10, we're going to charge a 10% small order fee. So that means that our boundaries are 1 and $1.01 on the positive side, and $9.99, and then $10 for that boundary for 10%. When we look at the next boundary, the more they order, the lower that service fee goes. So it's 5% when we're in our next partition. We have the boundary of $10. That's where that's the last too low for that boundary. $10.01 is when 5% starts instead of 10%. And then on the other side, $19.99, and then $20 is that final boundary. And then $20.01, now they don't have a service fee. So there's no more fee charged at that point. So that's how we would use these boundaries in this particular situation, and why we would specifically choose to go with 3 value instead of 2. If we went with 2 here, we would have a gap, because we would end that 10% service fee at $10. We would start the next service fee at $11. Between 10.01 and 10.99, there would be no fee charged, because there's a gap in there. And that's the kind of thing that this technique exposes, that we've incorrectly left a hole that we need to fill in. All right, so let's try this one and see how we do. This one is a little bit less challenging than the other one. I think that equivalence partitioning is actually the hardest hands-on thing I've ever created. So my apologies if it was extra challenging. So here, a bank pays out interest based on a customer's balance on the last day of each month. The interest rate earned is variable and increases based on the balance on that day. Less than $1,000, no interest is earned. $1,000 to $10,000 pays 1.5% interest. Greater than $10,000 to $20,000 pays 1.75% interest. And greater than $20,000 pays 2% interest. Using this 3 boundary value analysis technique, how many partitions, both valid and invalid, are present? And what are the test cases you would use to provide 100% coverage? If you can just do me a favor and put done in the chat again when you've completed. Ooh, Anna's fast.
No, Anna's probably wrong.
No, you're not. I'm sure you're fine. Done-ish, okay. All right, should we talk about these?
Yes.
Okay. So let's try this. Kind of made a handy little number line here. I'm going to go ahead and give everybody the ability to draw. Who wants to identify for me this first partition? Can you draw in for me the boundaries that would be present there? So specifically looking at, use a little highlighter so I can make sure you see it. Specifically looking at this area here. Can somebody try that for me?
I can try, but, oh, here, I can try.
Okay.
I've never done this before, writing on this on a go-to meeting. So I just take the pen here. So I know that this up here is, oh, see, is 1K, 1,000. Wait, hold on, this pen. All right, let me try.
I haven't tried to go to a meeting before. So.
Yeah, hold on, this is one. Wow, this is not easy.
Oh, okay. Maybe we won't do it this way.
Or unless it's me, but this is not, wow.
All right, I usually do this on Zoom. Lessons learned. My personal retrospective. Don't try and do this on GoToMeeting. Let me see if I can get it to draw better. Maybe because you're, maybe as the host, it'll let me do it better.
Yeah.
Let's see what happens. Okay.
Oh.
It's sort of works. We'll just put a 1 there.
Yeah.
And to make it easier, because I know where you were going with this, we'll put
Yeah. So then that's 99949. So that's no interest.
Yes. And then what was the other boundary here? The other side of the boundary?
The other side was the 1001 to 99, 9 to 1 less than 10,000.
Yeah. We're going to shorthand this to 1.01K.
Yeah.
Just to make it easier.
That's pretty much what I did. Yeah.
Who wants to do the next one for me? Who wants to tell me where the next one should be? Ryan, I see your. Oh, okay. Jonathan, was that you?
Yeah, sure. I mean, I can go if nobody else wants to. So for the next boundary, the lower end of the boundary is $9,999.99. However you want to represent that.
Yeah.
And then the boundary that, or the value that gets you 1.75%, first gets you 1.75% interest is 10,000.
Yep.
And then one above that is $10,000.01.
Ooh, lesson learned on GoToMeeting. All right, I'm getting the hang of this. How about this last set of boundaries here? Who can tell me what belongs there? Ryan, I'd seen your mic open earlier. Did you want to jump in?
Sure. So,
Okay.
so we are talking about the upper boundary. Yeah, that one.
Yeah.
That is 19,999.99 or however. Yeah, 19.99K and 20K on top.
My messy 20,000. And how about the last one?
That is 20,001. That is
Yeah. Yeah, it's like 20.
2.0.
Yeah.
Yeah.
You got it. Awesome. So here's what we would need if we were using these if we were actually building test cases around this. We would need a test case for $999.99 to make sure that that didn't pay out interest, for 1,000 to make sure that paid out interest at the correct amount, 1,001 to make sure it paid out interest at the correct amount, and so on and so forth. I want to challenge everybody. What kind of defects, like what do you think the defects would be that would cause mistakes in something like this, that would cause the wrong interest to be paid out, or interest to be paid out when it shouldn't be, or interest not to be paid when it should have been?
I think if you make a mistake on 1K with a rounding off,
Mm-hmm.
like if you round off 1.0001 to 1K,
Mm-hmm.
it may, actually that should be fine. I think 9.999.99, if you round it up to 1K, it could be a problem.
Yeah, exactly. We
Rounding
would
up
pay out
could be a
interest.
problem. Yeah.
Yeah, 100%. You were exactly right. We would pay interest when we shouldn't pay out interest. What other kinds of defects? Oh, sorry, Dennis, go ahead.
No, I was just going to throw one out. It's really not related to the partitioning, though, but I think the requirement said it's payable on the last day of the month or something like that. So a defect could be that it gets paid, the first day of the month, for example.
Oh,
Not
good.
related to partitioning though.
Yeah, I mean, it is kind of partitioning when you think about it though, because it more applies to that first technique. If we think about when that should happen, an invalid partitioning, when we think about timing, would be, should it have paid interest on that day? Or did that batch job that calculates interest run on the wrong day? Or did it run at the wrong time? So it happened at 11:59 on the previous day instead of at the right time on the next day. So that could absolutely be a defect. That's a really interesting one. I actually really like that. It makes me want to play a testing game with you all instead of doing pairwise. Maybe we'll do that because I kind of love this testing game I play. There's one other big defect that I'm thinking of that I wonder if anybody might be able to guess. Like, what is the mistake that would cause something to maybe, it would cause us to either be inclusive or not inclusive of a value that we should have in our boundaries? Meaning, maybe interest should pay out at 1,000, but it doesn't start paying out until 1,001 cents. What would that be? What would cause that?
Well, I can, from having written code myself, I can say probably from experience that if you incorrectly use greater than instead of greater than equal to, or vice versa, depending on what comparison you're doing, you can certainly introduce that defect by making that mistake.
Absolutely, 100%. And that's by the way what we catch the most using this technique. We catch either we have missed a set of values, and that's typically related to business rules not including them, so we left a gap, or we catch that the symboling that the developer used was incorrect, and so it was greater than or equal to, or greater than, and it should have been one or the other. This is super, super valuable, by the way, in automation and in unit testing. You want to talk about something that's going to save you a lot of headaches down the line? Build unit tests and automated regression tests that include this. And you can use this for all sorts of things. In finance, they use this for credit scores to make sure that only certain credit ratings are being approved for certain things. They use this for ensuring that you meet a certain income guideline. They use this for insurance scores. Anything that requires some sort of boundary between a rating or an amount charged, tax rules, you can use these kinds of techniques. I do really want to do that, that testing game with you all, if you'll indulge me. I hope that you'll all get as into it as other folks have. But before I jump into that and switch this deck to another one, does anybody have any questions about this partitioning idea or this boundary value analysis idea? No? I'm curious, do folks feel like this is something that they're able to make use of?
Yeah, it depends on what you're working on, but I think so for sure.
Yeah, I mean, certainly you have to be working on the right thing. And something to keep in mind is these black box techniques, we can combine this with other techniques. You can use this with exploratory testing. If you're doing some exploratory testing around boundaries, identify what those boundaries are and create test cases around it. All right, so I'm going to flip over to another deck for a second so we can try this testing game. This isn't actually one of my decks, like personally. So just keep that in mind. It looks very different. Oh no, come on, PowerPoint. PowerPoint and I always fight, by the way. We're not friends. We don't get along. I have to use it, but we don't get along. There we go. Also, PowerPoint and Macs don't get along. They're not friends. There we go. All right. We're gonna try this little testing game I love to do. I will be honest, I do this with people when I teach classes, and it's one of my favorite testing thought experiments. So this is specifically teaching about use case testing. I have a feeling y'all know how to do use case testing. But just to give a little background, these use cases are for kind of a mythical, imagined ATM machine. So we're developing a new ATM machine. The first thing we're doing is developing withdraw cash. Has some basic behaviors. Basic behavior 1, successfully withdraw from the checking account. Then we have these alternatives. Withdraw from savings, or withdraw from an overdraft account. For those of you who have maybe never thought of an overdraft account, this is just like a reserve account that you can kind of, if you overdraw your checking account, it pulls from the reserve. And some banks have it, some don't. 2 of these error messages or error issues are pretty common, like insufficient funds. We don't need any clarification on that. Amount requested is not in a multiple of 20, pretty straightforward. But it's this last one that I love to think about. And I love getting new perspectives. And every time I do this, I get new ideas of things to test. I think I'm up to like 25 unique test cases on this error 3. And you can ask me, we're going to pretend we don't have access to the product owner. I want you to think of tests that you would run, think of experiments you would run that will tell you more about or help you understand error 3 better. So the amount requested exceeds the daily limit of $300. What tests would you run to understand this better or learn more about it? Because there's a lot of question marks there.
Is that a question we should answer?
Yeah. Tell me, what would you do? What tests would you try?
Well, I think you could have a single test of, or a single withdrawal using that boundary value stuff. So like 299.99, 300, 301. But then you could have like, because the daily limit is not per transaction, it's for the day. So you could have the same concept, but multiple withdrawals in the day and make sure it's totaling up for the day properly.
Yeah, exactly. So we don't know how this does that total. If we take out, expanding on what you said, 100, 100, 100, 100, is it going to stop us when we go to take out that 4th set of 100? Or is it going to let us do it again? So we need to know whether it tallies that the right way. What else would you want to try to learn more about this and understand it better and expose whether it's working?
Also, the time of day that the day resets.
Mm-hmm.
So maybe you take out let's just, it's 12. So you take 300 out at 11:59. Then you come back at like 12, within seconds.
Yeah.
And just make sure that you still can get the money or that you can't, depending on how close the time is.
Yeah, so thinking about boundaries and time, but also thinking about time, what do we not know about this daily limit?
Yeah, we don't know what the day runs.
Yeah, we don't know. Yeah.
Time zone.
Time zone is something to consider. We don't know whether time zone will affect it. We don't know if it's at midnight or is it a rolling 24 hours?
No.
And if it's a rolling 24 hours, how does that change the way we look at these boundaries? Because if it's rolling and I take out $100 at 9 a.m., $100 at 10 a.m., $100 at 11 a.m., when am I allowed to take out $100 again? Is it at 9 a.m. the next day? Is it at midnight? Is it at another time? We don't know. So we don't have context there to tell us what a day is. What else would you want to know?
What does insufficient funds actually mean?
Oh, insufficient funds?
Yeah,
So typically that means you don't have enough in the account.
Yeah, that is not defined actually.
It's not, you're right. And there's some interesting tests that you could run around this idea of insufficient funds combined with the error number 2, right?
Yep.
Yeah, because what happens if you have $19.99 in the account? You can't.
Yeah, true.
Yeah. Are you allowed to overdraw by a penny? Because it has to be in $20. What happens there? Any other things you can think of with this daily limit? I recently had somebody come up with a new one that I had never thought of.
Yeah.
Yeah. Go ahead, Anna.
Yeah. How about, is it per person? Because what if 2 people share an account? Is it the account that can't go over, or is it the person withdrawing, even though, I guess because you have 2 different card numbers, maybe?
Yeah. And that's a really good question. Actually, that's a new one. I don't think I've had anybody ask that. So what happens there? And now that opens up a whole nother set of tests, right? Because, oh, well, $300 for each debit card.
Mm-hmm.
How do we track that, that calculation? Because now maybe one person is taking out at 9, the next person takes it out at 10. When do you get to take money out again? That's another one I hadn't. So I've got 2 new ones in the past 2 weeks.
What about if they deposit? Does that, I assume by the requirements are that doesn't affect the withdrawal limit, but that would be an interesting test also to make sure the deposit doesn't affect the limit.
It would be interesting. I've kept this really narrow to just withdrawal because once we start expanding it, it gets really big.
Sure.
But I would be curious to see what happens there, because that could, I wonder if that would change things. Somebody recently asked me about currency conversion. Right now, the Canadian dollar is lower than the US dollar. What happens if I go to Canada and take out 300 Canadian? I'm only 4 hours from the border. I could drive home in the same day and go to take out more money in the US. Can I? Am I stopped? Does that put me over my daily limit? So a lot of questions, and a lot of them center around this equivalence partitioning and the boundary value analysis idea. So lots and lots of ways to apply these techniques to really put them to use and build meaningful test cases and learn more about our requirements. Because yes, this is a thought experiment. This is a testing game. It's an opportunity to kind of flex that testing muscle. But at the same time, these are the kinds of questions that we ask in grooming and at refinement. Like, what happens when I do this? Have we thought about this case? Have we thought about this scenario? Have we thought about how it's going to work in this situation? So these are all opportunities to do that kind of stuff. And by the way, I really, really like super nerd out on this kind of stuff. So this is not just because I teach testing. This is like seriously stuff that I like to think about. And I can probably tell you, I talk about it on Twitter. I teach it in like at conferences. I talk about this stuff. So instead of introducing a whole nother concept and keeping you till 9 o'clock at night, Jonathan probably wants me to wrap it up and ask for questions, right?
Yeah, this is a good time. So if anybody has any questions for Jenna, please feel free to ask them. And of course, thank you, Jenna, for this. This was all very, very good.
Oh, yay. I'm glad you liked it.
Anyone have any questions?
Oh, I see a chat message.
Oh, they said, thank you, Jenna. Good stuff.
Oh, you're welcome. You're very welcome.
Always like listening to what you have to teach.
Oh, thanks. It's always nice to see you. Feel free to grab me on Twitter. Thanks for coming and hanging out with me for a little while.
All right. Good night, everyone.